Okay, welcome back. Question number 9. The rectangle ABCDE represents a plowed field where AB equal to 300 meters and AE is 400 meters. Joseph needs to walk from A to D in the least possible time. He can walk at 0.9 meters per second on the plowed field and at 1.5 meters per second on any part of the path B, C, D. So this one is 1.5, it seems, meters per second. And other than, okay, let me, uh, right. So this path, the blue path, he can walk 1.5 meters per second. Other than this blue, any path, anywhere he can walk 0.9 meters per second. So that is the understanding from the question until here, right? So now he walks from A to C, then from C to D. Okay. The distance BC is X meters. All right. So firstly, let me again write the distance. So if this is 300 meters, this is also 300 meters because it's rectangle. So if this is the A to E is 400, so B to C is X, so C to D is going to be 400 minus X. Is it okay until here? So now we need to find the Joseph's time, total time. We need to find total time. All right. So basically he is walking from A to C, yeah, then C to D. All right. So in order to find the time, time is equal to distance by speed. We know that formula, right? So speed we have no problem, but we need to find distance from A to C. A to C distance, how do I find? You can see that this is a rectangle, so this is a right triangles on the edges. We know that. So I use Pythagoras theorem here. So this gives me 300 square plus x squared because this is a hypotenuse. So let me write AC is going to be square root of 300 square plus x squared. Is it okay until here? So the time from A to C is going to be square root of 300 square plus x squared, distance divided by the speed. So you can see that from any part of the plowed field is 0.9 meters per second except on the BCD, except on this one, anywhere it's going to be 0.9. So I'm going to take this one as 0.9. Is it okay? Now time taken, let's write here taken, time taken from C to D because he's traveling from A to C and C to D. Okay, C to D is going to be, what is the distance? 400 minus x divided by the speed is on any part of the path BCD, the speed is 1.5. Now we want total time. So from A to C and C to D, total time. Square root of 300 square plus x square over 0.9 plus 400 minus x over 1.5. So we can just leave our answer here because the question didn't ask us to simplify or show that to any part. So we basically can leave our answer like this. Let's see the next part. Given that x can vary, find the value of x for which t is minimum. Okay, t is minimum and hence find the minimum value of t. So we already found the total time here, right? So total time. So now we need to differentiate because we need to find the minimum value. So dt by dx. We need to find dt by dx. So dt by dx. Firstly, I'm going to rewrite the 6 marks. So it is a big question. Huh? So I'm going to rewrite this first. 300 square plus x square to the power of 1 over 2, 0.9 divided by 0.9, right? So I'm just going to write, yeah, and this one 400 minus x over 1.5, right? Okay, so for this chain rule, I will use the chain rule 1 over 2, 300 square plus x square. Remember the chain rule? Times 2x. Yeah, because x square in derivative is 2x. So I can cancel this. So this gives me, maybe later we can simplify. Then plus 400, I can write this one as 400 over 1.5 minus x over 1, right? So this is a number, so it basically disappears. Wait, what am I doing? This is we already dy by dx, right? So I will change this one to 400 by 1.5 minus x over 1.5. Yeah. So this is a number itself, it disappears, right? So now I'm going to differentiate x divided by dx of x is just 1. So this becomes 1 over 1.5. Can I write this one? Maybe I can simplify it down. So dt by dx is equal to x 300 square plus x square. Oh, I forgot here. Negative 1 over 2. Negative 1 over 2 over 0.9 minus, this is 1 over 3 over 2. So I will write it as 2 over 3. Is it okay until here? So this is going to be our dy by dx, right? So minimum value. So we need to set this one as at minimum value, means at a minimum value dt by dx is going to be 0. So I'm going to set this one total thing as equal to 0. So now I will substitute one by one. We still have a lot of space. Maybe I will, to avoid the problems of the space, I will divide this into two parts. Yeah. So first I'm going to send the negative 2 over 3 to the other side. It becomes positive. Then x2, I will send the 0.9 also times 0.9 on both sides. So it gives me 0.9, it gives me 3 over 5. Okay. So basically, you can see that I can write this one in the form of square root of 300 square plus x square is equal to 3 over 5. I cross multiply. This becomes 5x equal to 3 times square root of 300 square plus x square. So to remove the square root, I will square on both sides because we need to find the value of x. So this becomes 25x squared is equal to 9 times 300 square plus x squared. So 25x squared equal to, this becomes a big number, right? But anyway, let's try to solve. So 300 square times 9. Yeah, yep. 300 square times 9. I will just write it as 9 times 300 square plus 9x squared. Is it okay? So now I will bring all the x squared terms together. So this becomes 16x square is equal to 9 times 300 square. So x square equal to, basically let's write x equal to directly. X equal to square root of 9 times 300 square over 60. Let's see what will be our answer. 9 times 300 square over 60. This gives me x equal to 225 meters. Yeah. So if x equal to 225 meters, that is not our final answer. He's asking find the value of t when the value is minimum. So substitute this x equal to 225 in the total time which we got in the beginning. So then our answer is going to be 0.9 plus 400 minus 125 over 1.5. Then our answer is going to be 533 seconds, or you can write it as, if you want to write it as a exact value, you can also write it as 1600 by 3. Both are okay. So this is our final answer for T. Okay. Hope this helps. See you in the next video. This is basically a question. Yeah. See you. Bye bye.